I'd like to start off by telling you a story about a guy named Dan. So this is Dan. He's a mechanic and his job is fixing spaceships. So here you can see him at the station bar, having a beer that is technically derived from fungus, but he's used to it, he's enjoying it, he's having a good time. And Dan is really a metaphor for all of us developers, because like any developer, Dan is going to go through the cycle of being cautiously optimistic, falling into a pit of utter despair and confusion, but he will come out on the other side feeling like he's understood everything. So my name is Max, and I have gone through that cycle of disillusionment and understanding many times in my life, and I'm hoping that with this talk, maybe I can make it a little bit easier for all of you. So as you probably guessed, this talk is about monorepos, and I work at a company called NX. We do monorepo tooling, and I also work inside a monorepo all day, every day, so that's my perspective on things. Just to give you an overview, I'm going to start off by talking a little bit about polyrepos, which I would say are the current standard way of developing software, what they do well and where they fall short. I'm going to talk about monorepos, what issues they solve, but also what issues they potentially introduce and why we need good tooling in order to fix that. So as I said, I want to use Dan and his job fixing spaceships as an analogy of sort to get my point across. So remember, in the next few slides, one spaceship equals one repository. All right, so on the first gig that Dan hires onto is actually a fleet of spaceships. In the front, they have some, fast ships. They're fighting space pirates, they're exploring, they're doing all the cool main character stuff. In the middle, there's some utility ships, and they're just handling repairs or transporting crew. And way in the back, there's some ships that take care of supplies and communication with the home station. So all of these have distinct responsibilities in the fleet, and they're all connected in some way. And I think this is a very logical way of organizing a fleet of spaceships like this. And it transfers. I would say this is a very logical way of organizing code as well. So the great thing of this is team autonomy. If we have one repository, or one spaceship in this case, for each team or each project, each team can make their own decisions inside that project, do what they do best in their domain. We also have technological autonomy. So you can see in this example, some teams are using React, there's another team that's actually using Angular, they can share some code with TypeScript, and the backend is written in Kotlin. So the cool thing is, because all of this is structured, this means, sorry, one second. All right, because this is all structured, it means we have a clear architectural overview of this entire system. So to summarize, I would say that polyrepos are great because they offer you team autonomy, technological freedom, and a cleanly separated architecture. But let's have a look at where they fall short. So let's imagine the web app team and the landing page team, they want to share some code, right? They want to factor out some shared React hooks that they want to both use. How would they go about doing that? Well, in this case, they would have to first set up a new repository, set up linting, testing, and building. They would have to set up a CI pipeline, publish it to some shared registry. Then they have to make PRs in the other places where they actually want to use the code. And then only can they test everything together. So as you can imagine, this leads to a lot of code duplication because no one wants to go through all those steps. So they're just like, this once I'll just copy this code over, and of course it's not just once, it happens all the time. And now it's completely separated and decoupled. So the code that exists in one place doesn't know about any of the other places. Maybe there's a bug that's found in the code. The other teams that use it are never going to know about the bug. As you can imagine, this does not scale very well. So as the project grows, teams are always going to be on different versions, scared to upgrade and introduce some kind of breaking change or the like. But even if we look at just the front-end portion of this, Let's say one of those bug fixes required a React version upgrade. You know, everyone started out on the same version and in sync, but then life happens, kind of. Some teams can upgrade, others can't because there's a blocker, and now everyone is in different React versions. And nothing is stopping them, in this case, from importing components from one another. Who knows what could happen if I import a component from React 17 into React 15? It might work perfectly fine. It might break horribly somewhere down the line. And the same goes for back-end, front-end relationships. So let's say the back-end team has some shared interface that they expose via an endpoint. If they break that without coordinating well with the front-end team, they might just break them completely in production. So as you can imagine, in the end, this results in a kind of state of constant fear, where everyone is afraid of moving, of upgrading, because they have this fragile equilibrium that they built, and they don't want to break it. So while polyrepos are great, especially for team autonomy, they also cause issues because of inefficient code sharing, because of high code duplication, and because of complex dependency management, all of which ultimately result in isolation. So Dan has been through all that, and he's not happy. Like, he just spent weeks trying to fix issues that should not have been there in the first place. He has sat hours and hours in meetings trying to coordinate with all the other ships, and he's back in the bar, he's drinking, but he's not happy this time. And I can sympathize. But then he finds a new approach, the monorepo. So instead of a fleet of ships, they actually just have one large ship. They still have autonomous teams in there working on their own, but they all share one large ship. And it seems like a daunting approach at first, but it has a lot of benefits, which we're going to learn about. So before I dive too deep, I want to kind of get aligned on what a monorepo really is. So I like this definition, which reads, a monorepo is a single repository containing multiple distinct projects with well-defined relationships. It's quite a mouthful, so let's go over what it means. The first part seems pretty obvious, right? Multiple distinct projects. If I have just one application in a repo, that's not a monorepo. That is probably a monolith of some kind with no discernible internal structure. So I definitely need multiple projects. But even if I just add 3 apps in a folder, that's not a monorepo, that is code co-location. And that brings us to the second point, well-defined relationships. So as soon as I start breaking out certain pieces of that code and establishing clear relationships between all those projects in my repository, now we're talking about a monorepo. And it has a lot of benefits. The first of them is atomic changes. So do you remember all that was required in order to make a fix to a shared library in that polyrepo setup? You have to make a PR to the library, test it, publish it, and make other PRs wherever you want to use it, test everything together, and maybe you have to go through it again and again. Well, in a monorepo, this becomes really simple. Because those apps import from the shared folder directly, I can just make a change to the folder, and it's used instantly in all the other places. And as you can imagine, this makes code sharing a lot easier as well. So instead of setting up a new repo and everything, I can just create a new folder, import from it, and that's that. And in turn, code duplication becomes way less, because people don't have this huge overhead anymore in order to share some code and reuse it. They'll gladly do it if someone else has done the job for them already. Because everything is in one repo now, we can very easily have workspace level dependencies instead of individual dependencies. We call this a single version policy. So let's say I have one React version, I have one TypeScript version, and the like. Now all my projects share that version, and I don't have to worry anymore about any of those hard-to-trace bugs where I'm importing a React 16.1.4 component in a 16.1.3 application. And by extension, creating new projects becomes way easier as well. So I can just set up a new repo. I don't have to worry anymore about my new CI tooling or about testing linting or about any of those workspace dependencies because they're already all there in the workspace. And that brings me to my next point, which is consistent tooling. So as you can imagine, in a polyrepo world, everyone finds their own solution to problems, right? And that's great. We want the team autonomy. But it could be simpler. There are things that can be shared. Let's say certain teams agree on one way of building things, on one way of testing things. In a monorepo, they can do that. And then they can share a lot of configuration. And that means that when any developer goes into any of those projects, they'll instantly know their way around, and everything is built consistently. So, in summary, I would say that monorepos really give you three things: velocity, safety, and mobility. And all these things I talked about, they contribute here in different ways, but I'm not going to go over all of them. But just an example, atomic changes, which is really important. They make sure that everyone can easily and quickly commit code that across the entire stack, the entire repository, so that's really fast instead of juggling versions around all the time. You can make sure that in any one state, the entire project works together. No more insecurity, making sure versions are aligned and stuff. Everything works together on any given commit. That's safety. And also, because any developer can really easily and quickly contribute to certain parts of the code base, they're more mobile to move around and contribute everywhere, so that's developer mobility. Monorepos require a certain level of collaboration though, and that's why I want to add this disclaimer. If your teams hate each other, they won't like working together in a monorepo. It seems obvious, but something that is often misunderstood about monorepos is people are worried about being too tightly coupled to other teams. And it makes sense, especially if they don't like those other teams. But that's actually a misconception very often, because in a monorepo, you still have complete autonomy over who contributes to your code, over what kind of technologies you use, and when you release or publish or deploy a new version. But still, there is a certain validity to the argument, and that's why I would say there is a certain level of collaboration that is required to work together in a monorepo. For example, you need to agree on the monorepo tool you use. That's like the very baseline. You probably also have to agree on the CI tooling that you use. And if your teams hate each other, they won't like working together. Then again, you probably have an organizational problem, not a technological problem. I really can't help you with that if your teams hate each other. But it allows me to make another really important point, which is that monorepos are not an all or nothing kind of thing. So we at NX, we build monorepo tooling, and we still have multiple repos. We have one for the NX open source code and plugins. We have one for NX cloud and infrastructure and closed source code and the like. And we have one for the editor extension, which is separately versioned, and it's mostly historical reasons, honestly, that it's in a separate repo. But that's fine. Most of you probably aren't Google. You need to have one gigantic monorepos where tens of thousands of developers commit. You can just incrementally adopt it, group things together where it makes sense. You can have multiple repos. It's fine. All right. So I think we can all agree that monorepos are great. I hope you're all as excited about them as I am, or like half as excited about maybe. And I'm going to be using NX in this next section to talk about where we could face issues, maybe, and how good tooling can help with that. I want to give a shout out though to this site, monorepo.tools, which is a great comparison over different monorepo tools, because there's not just NX out there, of course, and all the authors of those tools actually contributed, and it's as unbiased and up-to-date in a comparison as it could be. So definitely check it out. I'm going to go out on a little bit of a limb here and make a very bold claim, which is running tests takes time. I know, maybe it's not the hot take I thought it was. But the thing is, if we then have a monorepo and we have a lot of projects with a lot of tests each, doesn't just testing my repo become bigger and bigger and take longer and longer as it gets, as the repo grows? And the thing is, yes, but with good monorepo tooling, it's not going to be a problem. So how can we make it faster? By analyzing source file imports and through configuration, NX can build this project graph of your workspace. You can see here, there's a card application, there's a product application, they probably use some micro front-end module federation thing, which you're going to hear about after my talk. And they have some shared libraries, and then they have some libraries that they only use themselves. And with this, it's actually really easy to detect what is affected by a certain change. So let's say I make a change to the product detail page. Because of this project graph, NX can tell that the product application itself is affected. And in turn, we need to run all the products end-to-end tests as well to make sure everything works. But there's no way I could have broken the card app, because no path through this graph goes from the card app to the product details page. So you can see we can already save a lot of time by just running tests and build for 3 projects instead of everything. This also simplifies CI time by a lot. It simplifies your CI setup by a lot. So we can just say, hey NX, please run test, blend, build, and end-to-end tests for everything that is affected by a certain change. And that is it. That is your CI setup now. That means that we've successfully uncoupled the time it takes to run CI from the size of your project, or the size of your workspace. Now, it's instead relative to the size of the change you're making. So if you have a very small change, it's only going to take a little bit of time. If you have a very big change, it's going to take a little bit more time. All right, how can we make it even faster? Let's say I want to run a build. There's a lot of things actually that go into deciding what's built here. We have some source files, we have some configuration, etc. Those all get together, some computation is done, and we have an output. In this case, a JavaScript bundle and an HTML file. With NX, we add a computation cache. So how this works is we take all these inputs, we can calculate a hash from them, and then we save that hash together with the encrypted inputs in the cache. And the next time I want to run my build, I can just calculate the hash again, and if it's already in the cache, I can just restore it from cache, and I don't need to do any computation. And that means that my build can go from minutes to milliseconds. And the really cool thing is that this can be shared across all of your developers in an organization. So in a big monorepo, someone is always doing something, whether that be my colleagues halfway across the world, or a CI runner doing nightly builds or whatever. So if I log on in the morning and I want to run my build, chances are pretty high that someone has already done that exact same computation for me. So that means that in a monorepo with a distributed cache, we can make sure that no computation is ever run twice, ever. All right, so that's pretty cool. We can save a lot of time. And it showcases why it's important to structure things out into libraries. They're not just your fundamental units of architecture, they also allow NX to make way more granular decisions when it comes to calculating affected or doing caching. So this is great, but what if I change something further down in the graph? That means that potentially a lot bigger portion of the entire app, or even everything, is going to be affected. How do we deal with that? Well, NX has something called the task graph, and it's built out of the project graph and configuration. So here's an example from our VS Code extension, and you can see that in order to build the VS Code extension, we first need to build the language server and the generate UI, and then we can combine everything. And because NX has this task graph and knows how everything is connected, it can do some really smart assumptions here. We know what can be run in parallel. We know the order in which things need to be run to ensure a correct build. And ultimately, we can build the VS Code extension and have a correct, fast build. So as you can see, this is already a lot faster if we run it this way than just running everything sequentially, right? Because we can parallelize. But let's be honest, there is only a limited amount of parallelization we can do, and we have to handle the worst case here, right? Where everything in the entire repo is affected by a change. So there needs to be some other way to deal with this. We need to distribute all this calculation across multiple machines somehow. Let's get back to our example of running affected, build, blend, test end-to-end. In a bigger change, potentially that's a lot of tasks that are going to be spawned from this that have to be calculated. And a naive way of distributing this across multiple machines might be, hey, let's just run one type of task on each agent. But as you can see, this is actually pretty inefficient, right? Because while agent 3 is running, all the other ones are just idle, wasting time and resources. And there's another reason why this won't work in reality. Do you remember the task graph right there? dependencies between all those tasks. So in this case, for example, end-to-end depends on the build to be run first. And that means that we need to make sure that end-to-end is run on the same machine as the build. Otherwise, they wouldn't have the artifacts. So you can see how suddenly this is becoming a really complicated problem where we need to make sure that everything is run in the correct order. Everything is run on the correct machine where it needs to be run on. Everything is as efficient as it can be without any idle time, and we don't want to duplicate any tasks. And that's really complicated, believe me. But with NX, it becomes pretty easy, actually. It's just one line of code. We can say, hey, please distribute this across 4 machines. And because we have the task graph, we can make sure that everything is run in the correct order. And because we have the distributed computation, we can completely ignore that other limitation of saying the end-to-ends need to be run on the same machine as the build. We have this really fast way of replaying a calculation, so we don't really have to care about that. Agent 1 can run the end-to-end test, replay everything from cache, and it doesn't make a difference whether the build was run on that machine or another or in another country. So this is really powerful. And now that we have this one single line of configuration to distribute things, we can start playing around with it. Let's say we want an even faster CI time. We can just spawn a couple of more agents and it's reduced. Or let's say there's something that isn't actually that time critical, like nightly builds. We want to save some money. We can just use 2 agents instead. CI time becomes longer, but it's just one number that we're changing in the configuration, which you would be able to see. It's under the copy link in Right to Root. All right, so this is something that's really powerful, though. And it's really important because as your workspace grows, there's no way. At a certain point, there's potentially hundreds or thousands of projects in your workspace. There's no way to run it all on one machine if something at the root changes. So you have to distribute it somehow. All right, so after learning about all this, Dan is happy. You can see him. He's focused. He's doing work. He's not actually drinking for once. And if you want to be focused and content and have this amazingly chiseled jawline like Dan, I would recommend you head over to monorepo.tools and learn more about monorepos. Or you can, of course, just trust my completely unbiased opinion and head over to nx.dev and check out our documentation as well. So I would say Dan is happy, I am happy, and I hope all of you learned something. So all this I have to say is